All right, this video is on molar ratio problems. So here I have a balanced chemical equation. The blue numbers represent the coefficients that are going to allow the law of conservation of matter to be upheld. Okay, I have 4 atoms of iron on one side. I have 4 atoms of iron on the other side of the arrow. I have 6 atoms of oxygen on one side. I have 6 atoms of oxygen on the other side of the arrow. Okay, it's important to note that I am conserving the atoms. I am not conserving the moles. Okay, because if we add up the moles, here I have 7 moles here. 7 moles does not equal 2 moles. So I'm not conserving the moles here. What I am conserving is the atoms. All right, so now the type of problem you're going to do with molar ratio problems is I'm going to give you a certain amount of one of the species. In this case, there are 3 species for this problem. We have iron, we have oxygen gas, and we have iron 3 oxide. So I'm going to give you one species and an amount of that species, and you need to tell me how much of the other species is either going to be used or made depending on if it's a reactant or a product. So an example, if I gave, I had this much iron, I can find out how much iron, like number of moles of iron. I had X number of moles of iron. You should be able to tell me how many moles of iron 3 oxide I can make. Or if I had this many moles of iron, you should be able to tell me how many moles of oxygen will react with that amount of moles of iron. Okay, and I can practically go in a whole bunch of different directions, and with the following 3 problems, I'm going to give you this equation, so make sure you have this equation written down, box it in so you can see it readily, okay, because we're going to refer back to it a lot, because we need to go to look at these, the coefficients on a regular basis throughout this process, okay? So the next question, or the first question, is how many moles of iron would be needed to make 17.3 moles of iron 3 oxide, okay? So it's all of these molar ratio problems are all one-step dimensional analysis problems. And obviously, first thing that we're going to do is we're going to write down what is given, which is 17.3 moles of iron 3 oxide, which you can just write the symbol or the formula Fe2O3, and I put that over 1. It is important to note that there are 3 sig figs here. We need to pay attention to our sig figs once again. Okay? Now, I need what? What am I looking for? I need the moles of iron. So, if I look at my equation, okay, the number of moles of iron is 4 moles of iron, and I want to get rid of moles of iron oxide. How many moles of iron oxide do I have? I have 2 moles, 2 moles of iron 3 oxide. Okay, so I have what I want. I have moles of iron. So my moles of iron oxide cancel out, right? I'm going to end up with 17.3. My moles cancel out there. Times 4 moles of iron times 1 times 2. Okay? I would like to see this step, please, just to until we get more familiar with and get refamiliarized with dimensional analysis and with having to use 2 different species in our reaction. Okay, so doing the math, I end up with 34.6 moles of iron. Okay, so what does that mean? That means that I need 34.6 moles of iron if I want to make 17.3 moles of iron 3 oxide. Okay, so that's how much I need. Okay, right here. This is how much I'm going to need if I want to make that 17.3 moles of iron oxide. Okay, let's look at the next problem. So how many moles of oxygen gas will react with iron to form 33.64 moles of iron 2 oxide? Or excuse me, iron 3 oxide. So first thing I'm going to do is identify the number of sig figs. Here I have 4, right? So then I'll go ahead and write out my equation. 33.64 moles of iron 3 oxide. Okay, that's what I want, right? Or not what I want, what I have, what I'm given. Okay, what I want, okay, looking at the equation, What I want is the number of moles of oxygen gas. So what I need to do here is I need to use the molar ratio between iron 3 oxide and oxygen gas. So I'm going to go ahead and put this over 1. Oops, all of it over 1. Okay. I need moles of iron 2 oxide on bottom. And on my balanced chemical equation, I have 2 moles of iron 3 oxide, and I have 3 moles of oxygen gas. Okay? So, iron 2 oxide, iron 3 oxide cancels out. I have 3 moles here, so when I rewrite the equation, I'm going to end up with 33.64 times 3 moles of O2 all over 1 times 2. So you do the math. You end up with somewhere around 50. Let me see. Yeah, 50.46 moles of O2. Again, what does this mean? This means that if I want to make 33.64 moles of iron 3 oxide, I need 50.46 moles of O2. Okay? Go one more problem. How many moles of iron metal will react with 0.451 moles of oxygen gas when making the product? Okay, so we have to identify what we're looking for. We're looking for our number of moles of iron. Okay, moles of iron is what we want. Okay, moles of oxygen is what we have. So let's go ahead and start with that. Okay, so we'll go 0.451 moles of O2. That's what I have. Okay, put that over 1. Okay, make a note. I have 1, 2, 3 sig figs there. Okay, so I need moles of O2 on bottom. I want moles of iron on top. Okay, I'm not trying to find out how much product I'm making. It's just saying when I'm making the product. Okay, so I need to know how much of iron is going to react with 0.451 moles of O2. Okay, so it has nothing to do, I should not be finding anything dealing with the product other than these are the reactants that make it, right? So my molar ratio for O2 to iron is 3 moles of oxygen to 4 moles of iron. Okay, so looking at that, moles of O2 cancel out. I have my moles of iron, which is what I want. Okay, always make sure that when you're done with your dimensional analysis that you have what you want because you've already identified it in the problem. Okay, so equals this out, 0.451 times 4 moles of iron all over 1 times 3. Okay, I do the math, 0.451 times 4. Okay, now here's the thing, that's going to give me a, remember, we need to maintain our sig figs throughout on this. So if I have 451, that's 1.80. 1.80 divided by 3 equals 0.6. You don't have to add in the extra zeros on this. You can just go 0.6 moles. Actually, no, let's go ahead and stick with the rules. Those 0, 0 moles of iron. Okay? Okay, and what this means, I have 6 moles of iron is going to react with the 0.45 moles of oxygen to make our product. So just keep in mind, these numbers are, for the most part, they're absolute. If I have this many moles of oxygen, I need this many moles of iron because that's the molar ratio that my equation is telling me to use. Okay? Before we go ahead and finish off, I want to go back 1 slide and make a small correction. This should be 50.45, not 50.46, just to maintain our sig figs in the intermediate step that would happen in between here. The product of our numerators should have ended up with 4 sig figs, and I went ahead and divided when it had 5. Okay, so make sure that you get your sig figs at every step and then do your final answer. So 50.45 would be the answer for number 2. All right. If you guys have any questions, please ask.